every 90 minutes. The International Space Station could never have been built without the shuttle's payload and spacewalk capabilities. Space shuttles and Russian Soyuz and Proton rockets made more than 40 flights to construct the International Space Station, a true engineering miracle. All three of my orbiter missions were to the ISS.
Modules built by NASA partners in Asia, Europe, and North America came together above Earth over a period of 13 years to create a floating world longer than a football field and with more living space than a 6-bedroom house. A typical ISS mission requires an astronaut to live 6 months on board. But some crew members will spend a year learning even more about the very real physical and psychological stresses of long-term separation from Earth.
These missions and the 15 nations that designed, built, and crewed the ISS forever changed space exploration into a cooperative international program and made a true home and science lab like no other.
Wash away my troubles, wash away my pain, where the rain shone by light.
ISS system designs and scientific experiments have spawned a multitude of Earth-useful discoveries, including breakthroughs in water purification and robotic microsurgery. But most important, the ISS is our springboard to the future, giving us the knowledge and confidence to sustain human life as we explore deep space. Life on ISS is all about getting the job done and having a little fun.
Everyone is lucky, everyone is so kind.
And nationality is mostly about tasting each other's food.
Through 3 decades of camaraderie and dedication, 355 people rode the shuttle into history. They circled the Earth 21,000 times, and it all came to seem routine. Until it wasn't.
15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles.
This shuttle mission will launch. My God, there's been an explosion.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
In 2 accidents that stunned the world, we lost 14 astronauts. It was a sobering reminder that every space flight is charged with potential danger.
They had a hunger to explore the universe and discover its truths. They wished to serve, and they did. They were pioneers. The future doesn't belong to the faint-hearted. It belongs to the brave.
The world mourned, but pushed on, because the accomplishments of the Space Shuttle and the International Space Station were full of life-changing promise. In memory of our lost heroes, the global space community pulled together to reignite the future of both programs.
Who could ask for a better ending to my career as an astronaut than getting to fly the last shuttle mission on Atlantis and a final visit to the ISS?
Atlantis launch director, Gary Van Wall.
Atlantis, go.
So for the final time, Fergie, Doug, Sandy, and Rex, good luck, Godspeed, have a little fun up there.
We're not ending the journey today, Mike. We're completing a chapter of a journey that will never end. You and the thousands of men willing to give their hearts, souls, and their lives for the cause of exploration have rewritten history. Let's light this fire one more time, Mike.
Though the shuttles no longer fly, I never miss a chance to see Atlantis at the Kennedy Space Center. But I came to KSC to get a look at the next big step in deep space exploration, and it's called Orion. Here in the giant operations and checkout clean room, the new Orion multi-purposed crew vehicle is coming together.
What an impressive vehicle. Look at that. It's beautiful. That's gorgeous. I love the climb in there.
Orion is a true deep space exploration craft designed to carry astronauts of the future back to the moon, to asteroids, and even to Mars.
I've always been drawn to explore and try new experiences. Maybe that's why I applied to be an astronaut. I'm Serena Aughnan, and I'm one of the newer group of astronauts chosen by NASA.
Like the rest of my class, I'm absolutely honored and humbled to be here, and it's great to be a part of this team.
I guess you could say I'm one of those people for whom the future has always seemed an unfolding adventure.
So you can go forward and backwards in the procedure just by using this toggle switch from here.
Yes, exactly.
Learning from astronauts like Lee Morin, who have already spent weeks in space, gives you a great sense of confidence.
The Orion mock-up provides astronauts in training, like Serena, a chance to learn flight procedures and also give feedback to perfect new systems. This should be a piece of cake for Serena, since my shuttle's 10 screens and more than 1,000 switches have been streamlined to just 3 screens and 60 switches on Orion.
Hey Lee, you can open the helium crossfeed valve?
Okay, we got that go, so go ahead and send that command on the helium crossfeed valve.
Copy that.
And the shuttle's 100 pounds of flight manuals and checklists have been reduced to, well, 0, since Orions are all on computers.
Stand by and we'll evaluate.
But even with all these improvements, to get Orion into deep space, we're gonna need a bigger rocket.
When NASA's giant space launch system built by Boeing is complete, the rocket will stand as tall as a 38-story building and make more than 9 million pounds of thrust, enough to lift 22 elephants into space. For deep space expeditions, the SLS will need to lift 5 key mission components beyond low Earth orbit. Since Orion is too cramped for a 6-month journey to Mars, one solution being developed is an inflatable habitat to house the crew en route. A solar electric propulsion device will provide continuous power for the round-trip journey. A lander craft will carry the crew from their orbit above Mars down to the planet's surface. Months later, an ascent vehicle will lift the crew back up to the orbiting Orion for the return trip to Earth. But even using the most sophisticated future spacecraft, a 2.5-year round-trip journey to Mars will present new challenges to the human body.
I wanted to thank the Indiana State Museum for having me here. It is an absolute pleasure.
As a medical doctor with a specialty in aerospace medicine, I am particularly interested in keeping astronauts healthy as we head into deep space for long periods of time. Our experience with more extended weightlessness on the ISS has shown us that the human body will face challenges during lengthy journeys to deep space. Key issues are muscle and bone loss, which can start after just a few days of weightlessness, along with degrading of vision for some astronauts. We now know that exercise is the antidote for most problems caused by weightlessness. And I mean exercise, about 2 hours a day. But even so, the first explorers to Mars will need to rest at least a few days after landing on the planet to readjust to walking, though Mars has less than 40% of Earth's gravity. Radiation is another risk in deep space. Radiation radiation from our sun's solar storms is one source of danger. But cosmic radiation, which permeates all of deep space, is another ever-present challenge to human health. Sections of Orion, as well as the transit habitat, will have to serve as a shelter in the case of a major solar flare.
In the Arizona desert, an Orion mock-up is being drop tested to evaluate re-entry systems. On returning from deep space, Orion will enter our atmosphere more than 50% faster than shuttles or Soyuz capsules, and generate 5 times more heat. So perfecting her parachute deployment and heat shield is key to crew survival. At the Kennedy Space Center, Orion is being prepped for an uncrewed test flight into deep space. This new vessel marks the first step in over 40 years to put humans beyond low Earth orbit. A journey to Mars is on the horizon because of wide-ranging international efforts by both governments and private enterprise. Companies from Boeing and Lockheed to newcomers like SpaceX, Sierra Nevada, and Orbital Sciences are developing spacecraft to service the ISS and beyond. Some private groups foresee a technically simpler one-way mission to colonize Mars. Already thousands have volunteered to live permanently on the Red Planet. The demands of going to deep space will push old designs to new limits.
This looks good.
Hey, you're going. Should be good.
Sounds good.
My name is Lindsay Aitchison, and I am a spacesuit project engineer at NASA Johnson Space Center. I first started thinking about spaceflight when I was 4 years old, when I first came to JSC to take a tour at the visitor center. We have pictures of me just sitting inside this spacesuit, and I just knew that's what I wanted to do. When the Apollo suits were first done, those were very short duration EVAs. We didn't have a lot of mobility in that suit, so when you see those astronauts hopping around on the lunar surface, it's not because they themselves are clumsy or that the gravity is just impossible to deal with. We didn't give them enough mobility in the suits, so we learned a lot from that. For the next generation suit, there's still a lot that we don't know about what it's going to be like to live and work on Mars every day. Once there, we'd be doing EVA, walking outside on the planet about every other day. Once we have the hardware in-house, we become the experts of how that hardware works, what it does, and how it meets the needs for our next phase of our mission design. Get into the suits because the best way to understand how a spacesuit moves is to be inside of it and work it yourself. I'll be asking Richard to perform specific tasks, and what I'm looking at is what is his gait like. And so I'm watching how the bearings in the hip move and how the bearings in the waist move.